We'll continue on now with this 4.2 lesson. So now we'll talk about another type of function, solving square roots. So we did solving quadratics on the previous page. This is solving square root functions. This is another type of function, a real fun one, okay? And we will talk about what it looks like graphed in a little bit, all right? So for solving square root functions, we're going to isolate the radical or the square on one side. So again, the square root thing, actually, that should say just isolate the radical or square root. I should maybe have said. I've used these notes for years and I've never noticed that. Square root on both sides. And then to undo a square root, you square it. So step 2 says square both sides. And then you can plug your answers in and check it just like you did before. Now, when you do this problem, let's go ahead here, this first one, we're going to isolate the radical. So the square root needs to get by itself. So I'm going to get rid of this 2. And to do that, I am going to divide both sides by 2. Don't usually write it like that. Some students go like this, and their teachers taught them to do that, and then you divide both sides by 2. That's totally fine if that's how you divide. I don't know why I did it that way this time because I usually don't do that. I go like that. And so on the left side, I have x minus 3. And on the right side, I have 2. Okay, next step, square both sides. So once you get it isolated, you can square both sides. So I'm going to square this side, and I'm going to square this side. And then I will have here x minus 3, and on this side I have 4. Now, when you're doing square roots, okay, you don't have the 2 possible cases. And the reason is algebraically, the thing underneath the radical, okay, with this x minus 3 thing, it can't be negative. You can't, when we're in the real number world, which we always have been for you up into the later this year, we're going to start talking about numbers that aren't real. But in the real number world, you can't have a negative under a radical. So we don't need to consider, oh, what if x minus 3 is actually negative? It can't be negative because the number under radical always has to be positive with real numbers. So we don't have to consider this other option. So when you're doing square roots, okay, when you start with a square root function, you are, oops, what am I doing? You're good to go. We're going to add 3 to both sides to isolate the x, and we get x equals 7. Remember, if you want 100% on your next test, all you have to do is check your answer. So I'm going to stick 7 into that original equation, and I get 2 times, and then the square root of 7 minus 3. 7 minus 3 is 4. The square root of 4 is 2. 2 times 2 is 4. You have to do the operations underneath the radical first and then take the square root of it before you start like applying the 2 to the things that are underneath the square root. That doesn't work. All right, so now I think that you can go ahead and do B by yourself. So go ahead and do that. You should have gotten x equals 21. You add 2 to both sides. You then divide by 3. Okay, so when you do order of operations for solving, you do addition. So PEMDAS, I'm just going to remind you on PEMDAS. When you're solving, you kind of work backwards. When you're evaluating, like putting a number in, like I'm going to put 3 into this equation, you kind of go forwards. And when you're solving, you're isolating. So you're going to like do the addition subtraction first. That's why I added 2 first. Then I divide by 3, which is the multiplication division step. And then you can move on to the exponents, which I don't have an exponent in this one. I had a square root, but you kind of work backwards. So you should get 21. And then when I checked it, I got that 10 equal 10. So I got that correct. All right, moving on. This one, I believe, we'll do it graphically. In fact, I think what I'm going to do, or thought I would do, I will do D with you because it's a little bit more complicated, and then you'll do C after I get done with D, or we do D. Do D together. Okay, so here it says f of x equals the square root of x plus 2 and then plus 5. I'm going to stick 6 into this equation. So 6 equals square root x plus 2 plus 5. I'm going to isolate the radical, so I'm going to subtract 5. And I get 1 equals the square root of x plus 2. I have the radical isolated, so now I can square root both sides. Oops, sorry, my bad. Square both sides. So I am going to square, I'll write it down in the second step. Square root of x plus 2 squared. And 1 squared is just 1, and then this equals x plus 2. Subtract 2. X equals negative 1. So x equals negative 1, and I can check it by putting negative 1 back in. Again, you can kind of do this mentally. If you put negative 1 in here, negative 1 plus 2 is 1. Take the square root of 1. That's 1. 1 plus 5 is 6. I did want to show this to you graphically. So that one is, this one right here. And we said f of x equaled negative 1. So, excuse me, I'm looking at the wrong page, equaled 6. Okay. So x equals, or f of x equals 6 is this blue line, and then the purple one here is my radical. And by the way, that is what a square root function looks like. It's kind of like a hill. It starts, here, and it kind of goes up like that. We will be transforming those in the next chapter to kind of do a bunch of stuff, flipping them over axes. But if you look at that point, when the y value is 6, x is negative 1. So that is that one. You should now be able to go ahead and do C by yourself. So go ahead and do that one. So for this problem C, you should have gotten x equals 47. If I stick 47 into this equation, 47 plus 2 is 49. The square root of 49 is 7. When you look at this graphically, and we'll go ahead and do, oops, I always do that wrong. I'm going to put 7 in here. And that was this one. I have to use the pen for this for some reason. Usually I can use my finger, but it's being picky. All right, so I have this, and you can see that where they then cross is right here when x is 47 and y is 7. Another thing I just wanted to briefly talk about when we talked about when you solve a square root function that you only get the one answer. The reason you only get the one answer is because it only crosses at one location. There's never with a square root function like 2 different places it crosses. When we were doing the parabolas earlier, let me get back to my parabolas, then the parabola crossed at 2 places. So for a given y value, like this was 7 in this last one, there was actually, in this case, there would be 2 different places where it would cross, okay? So that is why you could have 2 answers for a parabola, but you wouldn't have 2 answers for a square root function. Moving along, we are going to go to absolute value functions now. So let me get up here to the top of the page here. So I have a little summary box here for absolute value functions too. So what you're going to do for absolute value. So for absolute value functions, you are going to, hold on. Got some problems with my stylus. I'll just show you, because this will happen sometimes when I'm doing videos. This is a stylus I like to use because it goes with my Microsoft Pro and it's really accurate. And sometimes when I go back and forth between decimals, then all of a sudden the pen stops working and I have to switch to this stylus during the video because I can't get it, I can't stop it, I can't fix this until the video is done. And this one's not as nice, but it still works. But when you see me struggling, that's what's going on. Some of my struggles, not all of them, because gosh, there's sure a lot of struggling. But that's one of the things that sometimes happens with these videos. Okay, so solving absolute value functions. So what we're going to do then is we are going to isolate the absolute value. So just like we were isolating the square root or isolating the squared part, right? We're going to do the same thing. And absolute values, just to give you a little review, because you learned these long ago, the absolute value of something means you take whatever the positive value is. So the absolute value of 3 is 3, okay? But if I have like the absolute value of -7, well, you take the positive of that and it equals 7. So that's what an absolute value does. So in this problem, here, and I am going to zoom up a little bit because, as I said, so we were talking about the steps. So we're going to check to see if it's negative. If it is negative, then we'll say there's no solution. And we'll talk about this as we do the problems. If it's positive, you're going to break it up into two possibilities because the thing inside an absolute value could be positive or negative. And then we'll finish solving and check it. Again, all this will make more sense in a moment. So here I'm going to isolate the absolute value. So I'm going to add 6. And I get the absolute value of x plus 1 equals 10. Now, step 2 there said, check if the absolute value term is negative. So what it's asking about is not about all the negatives in here. It's talking about the value that it ended up being, this 10 here on the right. Is that a positive number? Because if you say the absolute value of anything, and x plus 1 is what we have, but like anything, if you say it equals a negative number, like that's not possible. Absolute values only return positive answers. So this one's okay. So now we can say, okay, that x plus 1, that thing inside the absolute value, it either was 10 or it was negative 10, because it's possible that it was negative 10 and then we took the absolute value and we got 10. So we, just like we did when we were doing the square functions, we're going to say, well, two possibilities. X plus 1 might have just been 10 and we took the absolute value and we got 10. Or x plus 1 might have been negative 10. Now we're going to add 1, or sorry, subtract 1 from both sides to solve both of these. So I'm going to subtract 1, and I get x equals 9. That's one possibility. Or here, if I subtract 1, I get x equals negative 11. Okay? Check both of these. If I stick 9 in here, 9 plus 1 in the absolute value, the original problem, you get 9 plus 1. I see I can't, I'll just kind of highlight it as I go because I don't get my little cursor anymore. So if you stick a 9 in here, you get 9 plus 1 is 10. Absolute value of 10 is 10. 10 minus 6 is 4. That's correct. If you do it for negative 11, negative 11 plus 1 is negative 10. That's negative 10. Take the absolute value, it's 10. 10 minus 6 is 4. So that one definitely works for both the answers that I got. Moving to the right problem here. Now this one I want to talk about because I could just have you do this one on your own, but it kind of ends up being a special case, which you are going to like. I'm going to isolate by subtracting 11 right away. So you're supposed to isolate the absolute value. That's the first thing you need to do. This is going to be negative 6. Now I still need to isolate. There's that 2 there, so I'm going to divide by 2. And you get, the 2's cancel out, x plus 1 equals negative 3. This is where that step 2 in our little steps here is important. Check if the absolute value term is negative. So it equals negative 3, the right side there. Is it possible for that absolute value to deliver negative 3 to you? It can't. Absolute values only deliver positive answers. So when this happens, you can just say, hey, that's no solution. There is no solution to this answer. All right? So that's kind of nice because you just stop and you're just done. Moving to this problem here. Now, these are the graphing type, right? We are going to find x when f of x is negative 49. So again, we will go ahead and put negative 49 into this equation. And from here, I believe you should be able to solve this. It would be similar to the green one that you see above. So go ahead and do that. Okay, so I stick negative 49 into my equation here. We added the 1. We did, well, no, we did not do that together. So there's that. Then I need to get rid of the negative 3, so I divide by negative 3. That makes this a positive number. And looking at this, according to step 2 above, is it possible that the absolute value would give you or deliver you a 16? Yes, it delivers positive numbers. 16 is positive, so that's okay. So it's possible the x plus 3 was 16, and I took the absolute value and got 16. Or it's possible the x plus 3 is actually negative 16, and when you take the absolute value, you get 16. So I have both those cases there, and you get x equals 13 and x equals negative 19. Up here in green, I did all my checking. So if you had any issues with the checking, you can go ahead and take a look at my work there. Now, I wanted to show you this then. If we go to Desmos here, and I look at that one, that is this one, I believe, and we set it equal to negative 49. Just to prove that this works. Okay, now an absolute value function looks like this kind of thing. Okay, I'm going to just reset this screen. I'm going to hit home because my scale is kind of messed up there. So it's this black one here. I'm going to get rid of this one. And an absolute value function is a V function. This one happens to be upside down, but that's what absolute value functions look like. And at negative 49, if I zoom out here, at negative 49, you can see that it crosses at 2 locations. It crosses at when x is negative 19 and when x is 13. So there's those 2 possibilities. Now it's possible if I had picked another value like this value right here, okay, if I instead made y negative 1 just to kind of force this, I'd actually have one solution because it only hits there at that one point. It's also possible, and this is what's going to happen with the no solution problem that we had earlier. And now, let's say that the y value I'm looking at is 10. Okay, when you have something like that, you have this horizontal blue line up at 10, and the value of the function is way down below. This is an example of no solution. These things never cross. That's why you get a no solution, because it's not possible. So that's what went on in problem B, okay, where you didn't have to finish solving it. You're probably like, yay, right? Let's do this last problem here. What do you think? You think this is going to be a no solution problem? Or you think it's going to be we had to solve the whole thing through? You have to know me maybe a little bit better to know. What is she going to give? Well, it's probably, well, I'm not going to say. Let's just get this done, right? Okay, so here we have this function, f of x equals 6 plus the absolute value of x minus 2. Find x when f of x is negative 1. So when f of x is negative 1, I have this. I'm blaming the stylus on the fact that those x's look like that. I subtract 6. I get negative 7 equals absolute value of x minus 2. So I isolated the absolute value. And then that step 2 says, determine if the absolute value could really give you the answer. And here, like, could your absolute value ever give you negative 7? The answer is no. You can't have an absolute value deliver you a negative number. So once you isolate the absolute value, look at the number on the other side of the equation. If it's negative, then it's not possible. So this is no solution. And just double checking here, because I have that one here. And if I say the value, which was negative 1, You can see now this is an upright parabola here, this one, but you can see it's no solution because the horizontal line -1 and the absolute value function, which is red, they never cross. And so that is why it is no solution. Now you could get no solution answers for like parabolas too. Like this one, that is, there's a solution, or there's two solutions, right? Because it crosses twice. But if I made this like -9 or something like that, oops, that's -9, -9, this would be an example of no solution. We're not going to give any of those to you. We usually are doing it when it's an absolute value function rather than quadratics, but it's possible it could happen with square root functions too, where there's never a spot where it crosses. So hopefully the solving lesson has kind of helped you connect the graphs to solving and familiarize you with some of the functions that we're going to be working with. But these are all very important Algebra 2 topics. You really learn most of this stuff in Algebra 1, but you just really want to solidify it because we use this stuff quite often.